Welcome, everyone. I hope you've been enjoying and learning at Unreal Fest. As for me, I've been locked up in my room just practicing over. Nah, I I have been at many talks and it's been great so far. A lot of information. In fact, I've had to like jump between talks just to uh, glean so much information. But yeah, I'm Jacob Thomas. I'm a senior engineer at LightspeedLA, and this is my talk on enhanced validation, how we implemented validation at our studio. So the first question you might have is, who's that? Um, so we are Lightspeed LA. We are the first US-based studio from Tencent. And as you can see here, we have talent from all over. As far as Unreal goes, we were at Unreal 5.0 starting the project, and we have been upgrading with major versions. We are currently at Unreal 5.5. I'm handling our upgrade to 5.6. We'll see where that goes. But as you know, or you might have heard of AAA studios, most of them have custom engines. And as you can imagine, for many people, it is their first Unreal experience. A little about me. I have been in the games industry for a while. I started in QA on The Last of Us 2 with Naughty Dog. And then after that, I got the opportunity to be a support engineer at Insomniac, and we shipped the titles you see here, Miles Morales, Ratchet and Clank, most recently Spider-Man 2. And about 3 years ago, Lightspeed reached out to me about an engine programmer position, and I've been there ever since. These are some of my roles. As I mentioned, I deal with engine upgrades and integration, and if we need any mods for any particular teams, we also put that in. I have designed tools for design and art. And also put in our automation framework for um, specific to what I'm doing right now. I'm a systems engineer, mostly working on procedural frameworks and specifically roads on our open world game, which is Last Sentinel. Think of it like GTA in Japan. That's the short pitch. So an open world RPG set in futuristic Japan. And like many people at my studio, this is my first Unreal experience. So, quick show of hands, who here are engineers? All right, okay. And what about people in games? All right, okay. Because I was talking to a lot of people outside, and when I asked them about validation, it was like, oh, you mean like inner validation, like for your soul? Like, so as a game engineer myself, I have taken the liberty of sprinkling the slides with a lot of code. So I'm not going to go specifically into what the code says, but what the code means. So don't worry for everybody who are not engineers, just follow along to what I say. Thank you. And then this is the agenda that we have. I'm going to give a primer on like what validation is and what we did to implement it at our studio, what challenges we faced, and how we resolved some of it, or a lot of it, but there are still issues that you'll find out about. And then where we are at as a project, what we learned, and what we are working on going forward. So what exactly is the validation framework, right? So I define it as a framework in Unreal that alerts people about what's wrong. And it does give some features to fix it up. I'll get into that in a bit, but it's mostly about alerting people about what's wrong. And what do you do to enable validation? So first of all, we have the data validation plugin. And as you can see, it has a lot of dependencies in Unreal. So it's always recommended to enable this by default. But there is this little plugin that we found out about. It's called asset referencing restrictions. If you guys attended Jack Condon's talk yesterday, he also talked a little about this, but we found this really helpful. I'll get into that in a bit. As far as contexts go, meaning like when can you trigger validation, I've broadly classified that into two. It's manual and automatic. So what do you consider manual, right? So any asset in the content browser, you can right-click on it, and it has an option to validate. You can also validate assets plus dependencies, the option right below that. You can validate all assets from a folder. So you can right-click a folder, and you can say just validate. You can also validate all assets across the project. A little note over there, if it's a project like 1,000 assets, you might be fine, but at the scale we're at, we find that it mostly either runs out of memory and crashes the editor. So we do not recommend it if it's a large project, at least from my side. And then we have validating from the command line. You can just use the Unreal Editor command.exe for that. Coming to the automatic context, we have onSave, which means that every time you save an asset, it triggers a validation. And also on pre-submit, meaning you open the view changes window and you try to submit an asset, it will always fire whatever you set up validation for it. At Lightspeed, we find that it is better to focus on the automatic context because it's more consistent. People always save, people always submit, but you can't really, base your pipeline on people promising that they will do it themselves. It works to a degree, but in a pinch, it's always good to rely on automatic context. So where do we start at LSLA, right? This is the first question we asked, like why? Why do we want validation, right? The context here is that we did not enable validation from the beginning. It might have been a mistake, but I'll get into that in a bit. But we were considering at that point, this was in 2023, how we could improve our workflow and what we could do to enhance our pipeline, and validation came up. So we found that we needed to repair. There were a lot of assets that were not in a good state, and it was causing a lot of issues. And whether it be due to our lack of experience or there were deep-rooted issues that we couldn't really figure out because the issue happened months ago, and then we don't have a trace of what actually happened. So we found that, okay, now if we implement it at this point, it'll be better than we spend some months later down the line to fix up everything. We also need to explore, if it's breaking at this point, how bad can it get? We were not even at 1 million assets at this point, and we knew that we would get there eventually. So we thought that, again, earlier is better. And also, we were building an open world game. So according to what Epic recommended, enable world partition. And we knew that once we get into that paradigm, the file count is just going to explode. Everything is connected. Everything depends on each other. And it'll be really hard to get to the actual issue if we didn't have validation. So this was our tech stack at that point. We were at 5.3. We used Perforce for source control. And along with that came the Swarm system for code review. And we were doing our builds via the Jenkins system. So specific to how we wanted to implement it, we reached out to various teams and we asked them, like, what do we want? What is important validation, right? And they came up with a few things. So we already had many common warnings and errors coming up all the time. And they said, yeah, we really want to fix it. And then investigating further, we also found that certain asset types were throwing more errors than not. There were also specific studio workflows that were always running into issues, and they were like, "Please help us. We need validation." So, and then certain team requests, which I'll get into in a bit. So, based on all that, we decided on the following. So, we decided that we would upgrade some warnings to errors because at that point, we had a lot of warnings that were causing issues down the line, whether it be stale references, they were just sitting there, and then someone would check in based on that stale reference and then would break another asset. So we thought that, okay, if we have upgrades to errors, that'll be more noticeable. We also started with static meshes. They were the biggest culprits because when we investigated, like, what are the major asset types throwing these issues, it was static meshes. Also, if we wanted to validate, we also needed to have the principle on what is valid, right? So we wanted to define standards beforehand and then say, like, okay, team, here are the standard assets. This is what we expect. Otherwise, like, at that point, many teams were like, oh yeah, we'll just define our own standards and we hope that other people adopt it. But then everybody had competing standards. So that wouldn't just work. We also decided, like, early on, we knew that we would be upgrading engine versions. And there were a lot of usage of engine assets at that point. And in one of the upgrades, we found that, like, one asset was in a particular location, it was moved, and that was causing a lot of issues. So we said, okay, we're not going to go with engine assets. Wherever possible, it's not possible all the way, but wherever possible, we would rely on our own assets. So if we wanted to use something that was in the engine, we would import it into the project and use that. And also, we wanted the team to experiment, of course. It's a game, and we were doing a lot of experimentation. So we decided that developer assets, there's a specific content folder called developers, and we decided, like, you can do whatever you want in there. It will never get into the game, so we don't care. So that was, kind of relieving to many people because they were like, if everything is validated, how do I do this crazy thing that's not supported? So that was also decided. And then, okay, so now I'm going to go through a little bit of the code. So to upgrade warnings to errors, we defined our own custom macro in a central location like build.h. And then we went to a site of a common issue. In this case, if people have been using validation, this might be familiar. It's fail to load package, which is a very common issue with stale references. We went there and we did two things. We used our macro to put it as a map check error so that when the level loads, you would get the error. And also, we made sure that when it's an error, we would switch the context to the message log so that they actually see, oh, there are errors coming up. Otherwise, like, we found that people were just, oh, it's an error, it's sitting in the background. They wouldn't see it, or it might be easily ignored. So with this, we found that, hey, why is this error coming up? And people were messaging all over the place. And then, people could jump in and fix the issue. So as recommended by Epic, we also overrode the base editor validator class. And this is an example of the static mesh validator. So the important function is the validate loaded asset implementation. You could put all your validation logic in there. Everything else, decides when the validator is fired. So with this class in place, this is what it looks like in the editor. So we would make a blueprint, an editor utility blueprint out of that class, and it would be an asset. And then the asset would have the knobs and dials we needed. So for example, in here, we have the ignored paths, which means, as I said, the static meshes were in a bad state. So we wanted a facility to ignore certain paths until they were fixed. Otherwise, people would start doing some new assets, and then old errors would come in, and then there would be issues. So we had that facility in place in the validator. And as mentioned, we had standard assets. And the most common standard asset is the basic shapes. So when people wanted to, block out something, they would go here. And these were originally engine assets. So we overrode all that and made sure that, for example, the cylinder CMZ is our own asset. And it has its own naming conventions. You can see SM underscore. We have prefix validation, and we have our own material. And all this was done with this code. So we would have a custom level module with a specific delegate that we would override, so that when you load the editor, it actually loads our assets, not the engine assets. Similarly, we also had standard levels. So here you can see empty open world, which was completely blank, and a basic open world, which had some static meshes and lights. Both of these were world partition, which is important because by default, if you do a new level, it comes in as non-world partition. And since we decided that everything would be in world partition, we want to enforce that. And that was pretty simple, not much changes required on the code side. Just go to project settings and put in your levels, and that took care of that. We also enforced standard asset names. This is what that looks like. We had specific requests from our animation team, art team, saying oh, we want, for example, materials to come in with a specific naming convention so that we can search for it after the fact and identify it. Because outside the editor, you can't identify any U asset. So that's what this is. This is a data asset that has a mapping between classes and the prefixes. And for example, if you, like I mentioned, if you added a new material, it will automatically pull in from here, so the material M, and it would say M underscore material instead of I think, Unreal says new underscore material, which is not what we wanted. So this is what that looks like. So we would override, again, with our custom macro, saying hey, don't go to your engine default. Look at our standard data asset, pull in the mapping from there, and then we have the new name. Similarly, this is a special case, but it was important because a lot of designers were using the modeling mode. It's great, it's amazing, but the assets that come from it, they don't have any standards. So we had to enforce it there as well. As you can see here, we have underscore, which is our static mesh convention. We have the standard material instance. And we did that with just these two properties that enforced both of that. And they would come in as like, configurable properties in the project settings. So with all of that implemented, what were the results? Well, yeah, everything went great. All errors were fixed. Everybody was dancing. And thank you for, of course not. There were challenges. There were a lot of challenges. And let's go through some of them. It's not extensive, but these were the things that started coming up again and again. So for one, because like I mentioned, there were a lot of people coming from well-established studios. They were more familiar with the Perforce client than what we had in the editor. And although they look visually very similar, there were some fundamental differences. For example, we have a revert option in the editor. So when you revert it, Unreal is good about reverting that status from the Perforce server as well as locally from disk. But if you do the same thing from the Perforce client, unless you check that little box, which is disabled by default, the Perforce status gets reverted, but the file remains on disk. And then Perforce doesn't know that the file is there. And this caused a lot of issues because now you had stale files just sitting there, and they had active references, but Perforce didn't know about it. And when it came to Unreal, it didn't even know what to do with such files. Yeah, talking about Perforce, anytime we had any kind of connection issues, there were adverse effects. For one, like all the files that were out of date would go to something called the uncontrolled change list. And in many cases, the most egregious cases like stale files that sat in here for like 2 months, 3 months without people knowing that they were out of date. And then they would go to check in those files and they were already stale. So they would already have, reference issues. And then there was also the option for a force delete, which means like if you had active references, you could still ignore them and say force delete. And that way, all the stale references were left behind, and then some operation like redirector fix-up, which we did frequently, would not even know what to do with these stale references because the original path was already long gone. And then, in general, like the content teams found it really confusing as to what the error messages meant. So for example, like we would get things like, oh, this is missing from this change list, but I did not touch that file. Why do I want to include this in this change list? And then they would call us over, and we had to like figure out, oh, there is this thing that is down the chain that you had to include, but you did not. Similarly, like, invalid world assets, what does that really mean? There was no context. It was just like, here's the error, good luck. So there was a lot of that kind of ambiguity that existed. And this was a big one because the validator system mostly looks at assets. And if you have specific issues with actors, it doesn't catch that well. In this example, we had already an issue with the asset that was spamming the log. Someone would fix it on an actor saying like, oh yeah, okay, I fixed this issue, but it's still throwing the error. Why? Because it's an issue on the asset, not on the actor. And if there was a second actor with the same issue, it would still throw the same error. So this got confusing. In the reverse case, if there was no issues with the asset, but then the actors had like for example, in this case, it had an invalid nanite non-compliant material, it would still say, oh yeah, there's nothing wrong, nothing to see here, because the asset itself was valid. And yeah, we ran into this issue as well. As I mentioned, we were trying to not use engine assets, but when you deleted assets, Unreal would be nice and replace the deleted material with world grid material if there was nothing available, and that was an engine asset. We found that a lot of things just got auto-applied, and we didn't have any way at that point of dealing with it. So yeah, some UX issues. Obviously, like there were long dependency chains for container assets, like level instances, which had other assets within it. If we tried to validate it, it would just take way too long or run out of memory. Yeah, the legacy assets were causing friction because people would edit things that were dependent and not know why this asset is throwing an issue. If there were exclusive checkouts, this is kind of POFO specific issue, where if you had an exclusive checkout and you tried applying a blanket operation like an asset redirector fixup, what was checked out would not be changed, but it would allow that redirector to go through anyway. And then later on, because there were stale references, that would cause issues. We didn't have any integration on code review side to integrate like what was wrong with the asset, because first of all, like the assets were binary, and Swarm could only take in what was changed in text. So even if there were issues and it went through code review, there were some attached assets. We didn't know what to do. And interestingly, some non-U assets were being flagged as assets for whatever reason. But we kind of got around that later, which I'll get to. So yeah, with all these issues, what do we do? Where do we focus our efforts? So for one, we decided like this was important enough to dedicate some time. We made sure like whatever UI the Perforce client had, we would try to mimic it to a certain degree. So for example, this is a custom size, and we put in the change list number right on the title bar, and as you had many errors, you could scroll through them all within the window, versus like in Unreal, by default, you have to go back to the message log, and that was really cumbersome. Also, we enhanced a little bit of the view changes window where all the change lists are shown. So we had like a sort button, and then like we short-circuited the default change list to like create a new change list and conform to our standards. And also we enhanced the notification system to like have a little more context when errors were thrown. That original message was just like failed. That's it. So yeah, these are some specific things that we did on Submit. As I mentioned, like a lot of stale files were sitting in uncontrolled changes. This is what we did. On every submit, we took all the files and we converted them to the default change list. So that way, there were a lot of incidents of like, hey, why are like 3,000 files suddenly coming into my default change list? Now we know because it was stale change list. And this came up a lot when we implemented it, because as I mentioned, there were people sitting with stale files for a while. And also, this was a request from our content team as well. They said, like, I've fixed my issues, but when I check the error log, there are still those errors. Why is that? Have I solved the issue? I don't know. So we found it more helpful to like clear the message log when you validate it. So we would clear the asset check and the source control portion, and that way, like they knew for sure, like when you tried to submit, you would get the latest errors. So this is a big one. Revert from the editor did not work all the way. So it was mostly when you loaded an asset into memory and it was staying in memory, and then you tried to do something with it. And this was a constant issue. And what people would do is like, oh, I don't like this. Let me go to Perforce and revert. And then you would encounter that same issue where when you reverted and like you did not check that checkbox, you would again get into a stale state. So we made sure to unload the packages that were in memory when you reverted. And that seemed to work well. People are now reverting all the way. It's very rare that people revert outside the editor. So we also, this is an example of when there were new files that people were trying to delete it with active references. So we put in custom code so that if there are active references, that would be flagged and say, hey, this is a list of all the assets that you need to, either delete or make sure that there are no references before you can delete this one asset. And that also worked well. Many times we ran into issues with external actors because we had to go back to Perforce and find it manually, but at least it was taken care of before submit and it did not come into the package and cause issues. This is actually when we detected the issues on the actor itself. So when we detected that it was the external actor, we would actually take that and load it as a file object. And that was usually enough to make sure that the issues specific to the actor came through. And we also found that putting a limit on the actual dependency or the iteration count was very helpful. So, you had one thing that you changed in the level instance, and it had a deep reference chain. It would only take in a maximum iteration count so that only what you changed was actually validated instead of like, I have to wait like half an hour just to validate this single material change. So that's what we did with like including an iteration count. And this made it possible to actually iterate on container or aggregate assets. This is what I mentioned before, the asset restrictions plugin. In this specific case, we had a workflow that we had with our outsourcing partners where they would include files that were not vetted, and we had to make sure that these files did not get into the game. This was very hard because uh, the outsourcing assets had the same name as the actual vetted assets. So people would, when they were looking for the asset, they would constantly click on the outsourcing asset. So the moment we added like a rule saying like, hey, anything in that outsourcing folder is restricted, the moment they validated, it would come up saying like, hey, this is not allowed for submission. And this would like also throw up many other issues that already existed saying like, hey, you submitted this asset, this has an outsourcing issue. So we could clean up all that with just enabling that rule. Very helpful. And I'm going to give 3 examples of more specialized validators or validations on our project. For one, I don't know how familiar people are with this, but we had a lot of material instances with excessive amounts of material layers. And this was getting too egregious, and more material layers means more permutations, means performance hits. So we worked with TechArt to decide on a sane count, and we said, okay, you want to submit anything over our limit? Nope. You're going to go through this validation, and the moment we detect any kind of layer count that's above that, no, you got to fix it. Another special case is when we had scene capture components in blueprints, and they came in with capture every frame and capture on movement every frame. This was a heavy performance hit, as you can see. And we made sure in our blueprint validator that anything that came in that way, we would flag and we would tell them to fix. And if you needed to use such components, then you could enable it on runtime. Another case is when animation montages came in with animation sequences out of sync. We had a button to fix it, but no one noticed it, and it just went through submission. So we put in a specific rule saying like, hey, you have these things out of sync, so go click that button before you submit. And that worked out well. So where are we at in the project right now? As predicted, it's a little blurry. This is what you get when you try to process text in Excel. Sorry. But we are up to nearly 2 million files, and the vast amount is external actors, as predicted. And as far as asset types go, static meshes make up the majority. So this is a little on like what has changed when we implemented our enhancements. So for one, we couldn't predict the time to validation because there were a lot of issues that would either crash the engine or like go out of memory a lot. And now with all these enhancements, we are up to, on average, a few seconds to under a minute. As mentioned, aggregate assets, like container assets, were not really feasible because, for one, like the actor issues were not detected, and also like if they had long chains, it would cause other issues. But now with the heuristics in place, it's very manageable. And yeah, similar point, it got stuck or crashed before. But now that we know where the errors are coming from, we were able to I don't think validation has really crashed the editor in a while. It does run into some memory issues sometimes with legacy assets that have been sitting there, but it's also become very stable. Cook breakages were constant. This was like a really big issue that we kind of rectified with all these enhancements. We have probably like a breakage in Cook maybe once in 2 weeks or something right now, because there will be some references that have been sitting there for a while, but it's mostly like manageable. And also, this freed up a lot of time for engineering teams and tech art teams to go from like, hey, what's this issue? We got to jump on all these issues because content teams don't know what to do. Versus like now with clear messaging, we are able to give it to the content teams to handle themselves. So this is a timeline of where we are at. And what I didn't call out so far is this part where we implemented our custom tagging system. So we have a tagging on each submit with a specific hash so that we know that each submit has been validated. Otherwise, we had issues where there's this hashtag called hashtag changeless validated, and that is by default. So anyone who copies that hashtag into any changeless, they were able to bypass validation. So we implemented our own hash. And also we had like a dedicated support channel so that we could bubble up all the errors specific to validation. So what do we learn from all these? Invest early in validation. As you would have imagined, like all these issues might have been a little less egregious if we had invested right from the beginning, where we were in a clean state. And not only that, we actually built a culture around validation. It's like, how do we submit the asset? Oh, we need to conform to this standard and these conventions before you actually submit. None of that was there before we actually put in validation. Maintain health by default. What I mean is it is better to incrementally implement changes or fix issues rather than say, oh, let the issues keep piling up and we'll find like a month towards shift when we can fix all this up. That never works in games. There's always something to do last minute, and we definitely don't want to get bogged down by errors. Automate and enforce, yes. We found that if we have systems for validation and standards codified directly into the engine or as a configuration, that is way better than having a team or like specific individuals dedicated to validation all the time. That, you can never rely on that for too long because the team or the individual might have other things to do, and then this gets on the wayside. And it's everybody's business. The more people are involved upfront in validation, and also, them contributing to the standards, we can move as one, as a studio, instead of like, oh, we have the standard that we have been following for a while, and we need to now have a specialized part of the code only doing that. So that gets untenable in in a short bit. So it's better for everybody to have the same standards and enforce it that way. And it just made sense. So if you have not seen Sam Bass and Aaron's talk on Project Titan, I would highly recommend doing that because I found it really insightful on what they did with validation. So basically, it was a 3-month project, and they did not enable validation because they thought it would be like demoralizing to like implement it, which is fair. It was like an art jam, but they took a few weeks to clean up the project for a 3-month project. So you can see how valuable it was if they could implement it, but it was a different context. So what are we working on? Now that the asset issues are out of the way, a new challenger approaches, which is code changes that affect blueprints. Code changes that affect blueprints have been kind of really coming up a lot now, especially in the form of like broken pins or like entire functions omitted. And we are looking into ways of catching this, but nothing is final yet. And of course, this is shout out to Ari for releasing the submit tool. If you've not heard of it, it was something similar to what I talked about right now, but as a full-featured tool. There is no support, but I do find that a lot of things in this, for example, the Jira ticket link and stuff, could be very helpful. So we're looking into extracting what we can. And also there's a related Summit tool editor plugin, which will also be foraging for all that validation goodness. All the errors come in as text right now. There's no real self-serve. If people have to go and manually fix things. So we were thinking about implementing the action token API. So for example, in here, you can, if you have an error, you can like get a button to click on it and fix it. But shout out Ari again. He comes in clutch with saying that there's a data validation fixer framework that seems like it can do a lot more complicated things than just the action token icon. And we are definitely looking into that. And this is along with all the common validators that he already has up on GitHub. So the last few things, we are currently, as you would have seen, and if you are on validation, you know that the code that I showed is from an older API. And as of 5.4, they have upgraded to the data validation context. Which we haven't done already. So we're looking into doing that as soon as possible, which is what enables the fixer API that I just mentioned, and a lot more things that are customizable in the message log. We have moved to Horde, as you saw from the, well, I'm not going to go all the way. So in the timeline, we did upgrade to Horde at some point, and we are looking into how we can use pre-flight to enable validation for the blueprint breakages that I was talking about. So the idea is that if you have a significant change, like an engine change or a blueprint change, you need to go through pre-flight so that the cook errors are exposed beforehand. And that way, you don't break the cook, you only break the pre-flight. But yeah, it's still experimental. And also some studio workflows and certain teams have not really come into validation yet. There are many reasons around that, particularly like, teams like animation and cinematic, they work outside the editor for a lot, like in Maya and stuff. So we are still like working with them to see, and now that content is coming in, it's becoming hard. There are a lot of errors coming that way. So we are working with them to include them in the validation flow. And that's it. If you have any questions, let me know. But thank you so much for coming to my talk. Any questions?
We've probably got time for one question.
Okay. Yeah. I'll be in the dev launch for a bit. And
We've got time for one. If anyone's got a burning question, there's a burning question. Make it really long and complicated.
I've seen that you seem like have a lot of custom engine changes.
Yes.
So how you guys distributing the new version of the engine to the team members?
To the team members. Okay, so I know people have asked me about that. Why so many engine changes rather than maybe a plugin? We found that a lot of the things we were working with, we were kind of working on the bleeding edge. And every time we would like implement a system, maybe a version down the line, Epic would also implement. So we fully embraced making engine changes. And I haven't covered it in this talk, but that macro that you saw is part of our strict engine change standards. So as long as we implement that, we find that we can merge things pretty well. And we did the last engine upgrade in like a few weeks, I think. And then like there were issues that we had to fix up. So it has been pretty helpful to like maintain that standard, and that's our philosophy. Like we are okay with changing the engine as long as we conform to standards, so that it merges later on.
So it will take some time for the team members to download engines, merge.
Oh, I mean, no. Once we merge the engine, we have something called Unreal Game Sync that we have set up, and it automatically links to our now Horde system and cooks out the bandwidth. So that's not an issue at all. Whenever our cook times are down to like an hour, maybe. So every few hours, you can get whatever changes you want. It's not an issue at all.
Oh, I see. Thank you.
Yeah.
That's it.
All right. Thank you.